Alright, so question 2 in the midterm asks us, okay, let's look at part A first, right? So question 2 part A asks us how many ways in which you can arrange 4n different objects such that there are exactly n of type A or letter A, n letter B, and 2n letter C's, right? So you have, so you have 4n different objects, right? So let's say that's 4n. And you are given that you have n A's, n B's, and n C's. Now you want to be able to arrange your A's, B's, and C's within these 4n positions that you have. Now I'll give you two methods to do this, right? Let's look at one first. So first of all, think of it this way. First of all, I'm giving you 4n objects, and I'm just asking you to arrange 4n objects within themselves. How do you arrange 4n objects within themselves without even caring for now about the fact that you have duplicates? So you have 4n objects. How do you arrange 4n objects within themselves? How many different arrangements do you have? Number of arrangements you have for 4n objects is 4n factorial. Now you want to take into account the fact that you have many duplicates, because almost everything is the same. You only have 3 different kinds, right? So you have n different A's. To take into account duplicates in terms of A's, you want to find out the total number of ways you have double counted, or you've overcounted for A's arranging within themselves. So how many ways can you arrange A's within themselves in any given arrangement? So you have, let's say your A's are actually distinct. So you have n A's. But actually any given arrangement like this is the same as this arrangement, right? This, and any given way in which you can arrange these n A's among themselves, they're all equivalent, right? So you want to be able to take off or divide by the number of different ways in which you're arranging A's among themselves to account for the overcounting for A's. So how many different ways can you arrange A's within themselves? There are n objects. How many different ways can you arrange n objects? It's n factorial, right? So now you've accounted for A's. I'm just going to put brackets around 4n because it's not 4n factorial, it is 4n the whole factorial. Now you want to account for B's, but you see that it is exactly the same as the case for A's. You have n different objects and you want to avoid all the double counting by finding the number of ways in which you can arrange n objects among themselves. So you add another, sorry about that. Just gonna arrange that slightly better. Yeah. So now you have n. So this is for A's. You have another n for B's, right? And now again for C's. Now it's just that it's not n, but it's 2n. So this is for B's. This is for C's. So you have 4n factorial ways of totally arranging 4n different objects. But to account for the double counting of n different objects for A's, you divide by n factorial, and then again for n factorial for B's, and again by 2n factorial for C's, right? So the answer you have here is the actual final answer, and I'm doing this over and over again, Right, move that back into place. Now you want to now let me show you a different way to do the same thing. I'm just going to take this screen off. I'm going to start here, right? Second method to do the same thing. Now, don't think of arranging them first, but think of taking letters one at a time, one by one to begin with, right? So first of all, I'm giving you 4n positions. Now think of positions rather than objects. So you have 4n different positions, and I'm going to hand you a bunch of A's first. And I'm going to say put the A's into their positions to begin with. So how do you put n A's into 4n, like how many different ways can you put n different objects, n different A's into 4n positions? So you want to choose n positions out of 4n to fix the A's, right? So it's just 4n, choose n for the A's. Now you have how many positions left? You have 3n positions left. And now you want to fix the B's, right? So it's the same thing. Out of the 3n positions, you choose n for the B's. And out of the remaining 2n positions, you want to fix 2n for the C's. And this is for the B's. This is for the C's. But 2n choose n is just going to be 1, right? So this is equal to 4n choose n times 3n choose n. Now obviously you guys would want a sanity check to see if these two answers are equal. Let's just check that out. What is 4n choose n? 4n factorial over n factorial times 3n factorial, right? I'm going to put little brackets around these just in case you guys get confused. Now, how do you do 3n choose n? 3n choose n is 3n factorial divided by n factorial, brackets again, times 2n factorial. 3n factorial and 3n factorial get cancelled, so this just becomes 4n factorial divided by n factorial times n factorial times 2n factorial. So you see these two are just equal, and that's how you do question 1. Question 2 part A.